move to the panel discussion, and it was great for the audience here. And so I'm going to start with a couple of questions for each of you. And as we know, a lot has happened in hydrogen and fuel cells just in the last year. We've heard some of that from both of you. And so one question is, what do you see as the biggest opportunities for hydrogen and fuel cells? And as you know, this is the AMR. It's not quite working. So this should have had a fuel cell instead of a battery. Anyway, we have 1,000 people here from universities, from national labs, from companies. We even have investors. And so, as you know, it's our AMR. It's not a conference, even though it might seem like a conference, but we have the DOE-funded projects that are presented, they're reviewed, and we get feedback on our future plans, what are potential investments, how do we refine our work. And so we really have world-class expertise here, all types, not just vehicles, light-duty vehicles. We have our sister office, the Office of Fossil Energy, which includes the large-scale solid oxide fuel cells. We really have representation across all applications. And so, so the first question was really, where do you see the biggest progress and opportunities? But then the second question, I'll combine them, is from each of your viewpoints, what are some of the key R&D challenges that these researchers can tackle? We heard a little bit about efficiency, for instance, from Alan, but again, what's the most exciting progress just in the last year? So we're all convening again, it's already a whole year since we met. And then where are your top priorities for the R&D? So who would like to start?
Sure. Lots of questions there, Sunita, so I'll try to break them down a bit. I think the first question is, where have we seen lots of excitement and growth in the past year? And certainly from Plug Power, I would say, in material handling, of course. But obviously, the build-out in California has been tremendously exciting for the industry. And the push in China, I think, is significant in terms of trying to move that economy towards, obviously, zero-emission vehicles and making fuel cells a big portion of their push. So I think what I see as high-growth areas and excitement from last year are those. As we see growth moving forward, I think an area in which we believe will grow, and it's really because we can solve the fueling equation. That's in the area of commercial fleet vehicles. So we were able to be successful in material handling because we had a captive fleet. So that fleet of electric vehicles are within the four walls of those distribution warehouses. And we could solve the refueling equation economically. We could amortize the cost of that fueling infrastructure over lots of kilograms of fuel, many refuelings, and many vehicles. So we see growth going forward as very similar. And the next area for us is really commercial fleet vehicles. So when we think of those, we see growth in delivery vans, municipal fleets, city buses, areas that you can logistically solve the fueling equation and solve it rapidly. So we see those as high areas of growth.
So, Sunita, I think that from my perspective, it's through so many of the policy initiatives and the excitement that's out there. As you said, China has indicated a dramatic shift from just being a battery electric vehicle approach to a fuel cell electric vehicle approach. Our largest trading partner is Japan. And in December of 2017, so it's a little bit outside your 12-month window, but in December of 2017, Japan published their national hydrogen strategy. And it's really invigorated interest within Australia, and I think in many parts of the world, because of the clarity with which put forward the reasons why they're investing in hydrogen, how they will build up technological expertise and markets, and also clear targets for the volumes that they will import, the numbers of cars that they will expect to see on the road, the number of hydrogen refueling stations, and the price target. So it's just sort of laid it out as a target for everybody to move towards, and you've seen similar types of statements now out of Korea, and California is leading the way, and Germany is showing so much interest. There's enthusiasm in the air, which I don't think has been there in the previous runs of interest in hydrogen, and that is motivating for all of us. It's seen by virtue of the fact that the IEA, the International Energy Agency, has been asked to do a report on hydrogen for the upcoming G20 meeting. So hydrogen is on the global agenda through the G20 as well. So that's what I see as the most exciting things over the last 12 months. I think your second question was, what are the areas of R&D that are important for us to be looking to? Yes, I mentioned in my speech efficiency. You mentioned it in your question, and I'll just repeat it. When I first started looking in this area, and I'm a relative newbie, I thought, because I'm an engineer by training and at heart, that efficiency is the most important thing that technologists should be aspiring to achieve. And I was put back in my place and told, but it doesn't matter if the electricity is so cheap, the efficiency doesn't matter. But of course it does, because it affects all your capital investments. And if you're looking at hydrogen, as we and many other countries are, for seasonal storage to assist with incorporating variable renewable energy, solar and wind, you have to worry about the losses from the electricity that you're generating through storage and through regeneration. And at the moment, those losses are huge. They're not large, they're massive. And we'll never see round-trip efficiency as good as batteries, but anything we can do to improve that round-trip efficiency will make the adoption and utilisation of hydrogen more acceptable economically and to the community. And the second thing I'd say on needs in R&D, and again from an Australian perspective, is looking at the R&D involved in the shipping pathway. We're in a position where we will be producing lots and lots of hydrogen using solar electricity, and so of course the efficiency of the electrolysis is important, but so is the efficiency of the piping to the port and the compression and the liquefaction, if it's going out as liquefied hydrogen. The other end, the gasification or the regasification, is probably quite easy. But as I mentioned, an easier early way to ship large quantities of hydrogen is as ammonia. So instead of doing a physical conversion into the liquefied form, doing a chemical conversion into ammonia. And that's actually quite a high-density way of doing it, but there are energy costs involved in producing the ammonia. Can we bypass hydrogen entirely and just go straight from sunshine to ammonia? People are talking about that, and they're demonstrating it in tiny, tiny quantities in the laboratory, but that would be a bit of a breakthrough. And can we reduce the energy involved in the catalytic rehydrogenation at the importing end? And that's critically important, because if we in Australia are liquefying the hydrogen or converting into ammonia, and that takes a lot of energy, so be it, we're an energy-rich country. But if the country importing hydrogen from us, such as Japan, has to invest a lot of energy into extracting the hydrogen again, that's a real problem, because they're importing the hydrogen because they're an energy-poor country. So there's a lot of work to be done in that shipping pathway.
I certainly agree with everything that Alan said. I think that the key part in this market is the availability of economical hydrogen at the point of use. And from an R&D perspective, how do we make that happen? How do we lower the cost of production of hydrogen? How do we lower the cost of distribution of hydrogen? And how do we bridge that gap to be able to distribute hydrogen across the country in an inexpensive manner? And not only across the country, obviously across the globe. I think as we go forward, we need R&D, specifically in the area of low pressure, high density energy storage, and also low cost on-site generation for a more distributed approach are key to really making the large market go, which is really the future. So hydrogen to us at Plug Power is really the key, and being able to drive the cost, inexpensive distribution, and low-cost on-site generation is key going forward.
Great. So I think for all of the folks working on the DOE programs, you know, we have a number of targets, technical targets, and we actually talk a lot about cost and durability. But in fact, we haven't been talking that much about efficiency, but I think these are all really good points. I think we all know round-trip efficiency is a big challenge, and even on the fuel cell side, we've shown 60% efficiency, reaching the targets. So, you know, I think at good points in terms of keeping in mind efficiency in the work, and then also innovation, like the carriers. We're also starting to look at hydrogen carriers as well. So really a multi-pronged approach in the near term, gaseous hydrogen, you know, compression, the traditional pathway. As we scale up liquid hydrogen, looking at multiple approaches, carriers. I should mention that even though this is the US DOE AMR, we have many, many stakeholders from other countries here as well. So I think it would be good to get that, you know, global perspective. But one of the things we've talked about, you'll hear this throughout the week, is this whole concept of scale. So scaling up to help drive down cost, economies of scale, as well as individual technologies. And so one question is, and we know that infrastructure can be slow in terms of ramping up stations and so forth. So what are specific ideas for catalyzing infrastructure, bringing in other applications? For instance, the ammonia that you mentioned, you can use hydrogen, of course, for ammonia synthesis. So does hydrogen infrastructure have to be gradual? You know, we're seeing demand. We heard the 20 tons per day. And are there applications? What are some of the most viable applications in your mind to help us scale that kind of go across sectors? Is that question? And then I'm going to combine it again in terms of running out of time with, so it kind of feeds into this last question, which is we've seen a lot of progress in the last 10 years, in the last decade. And so if you could take out your crystal ball and see what would the industry look like 10 years from now, what would that be? So they kind of go together. So in others, we covered some of the challenges. We all know about cost, efficiency, performance, and so forth, getting infrastructure out. So again, the last two questions to get everyone from a global perspective, ideas on your vision, given all your experience. What are some opportunities to scale and to really accelerate, especially hydrogen infrastructure? And then where do you see the industry in 10 years in terms of your crystal ball?
My learned colleague is deferring to me to start. I wish that there was just a huge breakthrough that we could do that would build up demand, because if we had the demand, it would be easy for industry to respond. But it's not going to happen. This is a bit of a demand improvement in supply, demand improvement in supply. So we have to do it in a more smooth multiplier part. So think of solar panels. You know, if you want to build a solar station on your home, you put in 6 solar panels. But if you want to put in a 500 megawatt solar farm, you put in 500,000 solar panels. They're exactly the same solar panels. You just scale it up. I see transport as being a big driver. It's been unclear up until recently where the breakthrough will happen in transport. In your slide, Keith, you showed 6,000 cars, or you said 6,000 cars are already on the road in California and 3,000 in Japan, but that's a tiny, tiny number. And they're battling with battery electric cars. But in the heavy-duty transport, we've seen, again, you mentioned them, Nikola, Toyota, Kenworth, they're announcing big trucks. And there they've got a clear advantage in terms of distance and payload over the battery electric truck equivalents. So I see them as driving demand, and you need a lot of hydrogen, you know, a few hundred kilograms to fill a truck that's going to drive 1,200 miles between refuelings. So I see a lot of drive coming from the heavy-duty transport industry. We've seen it in Germany now. They've got a couple of hydrogen trains running, and they've got 10 more on order, so that's building up quite significantly. So heavy-duty transport is a clear incremental approach to building up demand. In Australia and in other places, we've been looking at injecting hydrogen at up to 10% by volume into the existing gas distribution network, basically for the built environment, for heating houses, cooking food, and heating water. And the beauty of that is that up till 10%, many studies have shown you don't have to change anything. You don't have to change the pipes, you don't have to change the appliances, you don't have to change the meters. It's 10% by volume, not 10% by calorific value, so you have to be careful about how you interpret the meters so that you're not charging people for energy that they didn't receive. And the beauty of doing that is you end up with quite a large demand for hydrogen, so you can build up your domestic hydrogen manufacturing capability. You get a lot of experience at handling the hydrogen, you get a lot of experience at safely handling it, and you start developing comfort in the user community in a very, very manageable fashion. And we haven't talked much about that, but the acceptance in the broader community is not a technological challenge, but it is a huge challenge as we bring a new fuel onto the market. All fuels are dangerous, and so is hydrogen. You asked about where it's going, but perhaps I'll hand over and then come back to that.
As we look out to the future, you know, the applications that will grow and 10 years from now will be well entrenched are those in which fuel cells offer the greatest value proposition. So those are long duration, highly utilized assets, long range requirements, and areas in which fast refueling is just a pure requirement. So we see the build out across the globe in these areas, as we've said, those tethered applications, municipal fleets. We see cargo trucks, heavy-duty trucking, where there really isn't another solution if you believe in the drive to electrification and if you believe the transport will ultimately be electrified, which I think certainly the majority of the people here certainly do. So we see a world 10 years from now where those commercial fleets are fully electrified, and we see fuel cells playing in all of those fleets in which you have high utilization, long duration, heavy payload requirements. We see that as a unique spot for fuel cells. When we build that out, that by its very nature builds out the hydrogen highway and the hydrogen capability across the area, and gives the opportunity to move into essentially the light-duty vehicle space. So we think it will be led by commercial vehicles, and then it will be followed by light-duty vehicles. We do envision a substantial amount of fuel cells on the road, and we do envision hydrogen spanning the country at that point.
And in terms of where I think we might be, I think you asked 2030, say 10 years from now, we'll have a lot of the hydrogen roadways, the refueling stations, the hydrogen highways underway in most of the advanced countries, but they'll still be sparse compared to what we've got with gasoline refueling. Basically, I think we'll be on the start of well established on the start of the journey, but it's a tough journey. And if we take the Hydrogen Council estimates for numbers of vehicles and energy use in 2050, I think by 2030 we'll be about 5 or 10% along the journey. We won't be a third of the way because it's one of those classic curves, the sigmoidal shape, but we'll be well established.
So I think the last question will be some numbers. I think people will be interested in terms of your projection. We have over 1 million, electric vehicles now. We have about, probably about 12,000 or so light-duty vehicles, hydrogen fuel cell cars now worldwide. So in terms of numbers, that'll be the end here. And then for those of you who come back to the AMR 10 years from now, we can see whether they were right. So how many light-duty vehicles 10 years from now? We won't ask you to project for all the other applications, but numbers.
1 million.
1 million
That's worldwide,
worldwide.
all vehicles. So we're counting forklifts as well? 2 million.
Oh, more than,
Okay, so Australia's chief scientist says 2 million, and from one of the leading U.S. companies, Plug Power, that has 25,000 forklifts in the market already. What's your projection for worldwide?
10 years from now?
10 years from
4 to 5 million.
4 to 5 million. Okay. So everyone write that down, and 10 years from now, the AMR will see who was right. So please join me in thanking our distinguished panelists.